Welcome back for a lecture series on normalized, digital image processing. The title of the present discussion is NDVI, that is Normalized Density Difference Vegetation Index. And this is the analytical part of digital satellite data. The digital satellite data is being analyzed to extract the information about the vegetation by using a formula, by using a standard formula. Normally there are many methods to extract, but for vegetation index, for vegetation stress, vegetation growth, vegetation health, if you want to analyze these issues with respect to right away of agriculture practice, this NDVA helps for a further remote sensing scientist. Once if we do normalized difference vegetation index, this will help in turn to the resources present below the surface also. So how we normally have to see the data depending upon our own interest. As a geologist, I could see from the rock type, as a base. As a geologist, I could see what sort of amount of water which is dominating, playing a role for the vegetation. I could see. Why I'm stressing, suppose if you are looking at the urban growth or rural development, whatever maybe it is, you know that the type of vegetation, it's again the backbone for agriculture. It is again the backbone for the healthy situation of any environment, maybe of urban or rural. This vegetation health study is very important. So indirectly, if you want to have a good air or a good health, you need to have good amount of vegetation. Like that you will get good amount of oxygen for your health. So with this intention, how to study the NDVI is likely to be discussed in the present discussion. We will discuss about the NDVI. As I said, we are now going to study about the green, live green vegetation absorbs visible portion as a part of photosynthesis from solar radiation. 100% it takes for generating food. At the same time, plants scatter. It means it is reflect solar energy in the near infrared. So there are two characters a vegetation plays a role. One, it absorb. The second one, it reflects. Absorb in visible band 0.4 to 0.7, and from 0.7, so it reflects the amount of energy it is going to be reflected. This is the basic principles of measuring the greenness of vegetation. By using this, greenness is likely to be studied. The NDVI is a numerical indicator that uses visible and near infrared band of electromagnetic spectrum, and is adapted to analyze remote sensing measurements and assess whether the target being observed contains live green vegetation or not. Very simple. By studying that, we could be able to say that what sort of health condition of the vegetation is there, and this is in turn explain about the greenness of the object also. So this is the exact definition. Is a numerical indicator that uses visible and near infrared band, as I said in the earlier slide, of electromagnetism, and is adapted to analyze in remote sensing measurements to assess whether the target of the observed contains live green vegetation or not. So NDVI has found a wide applications in vegetative studies. It will be able to help you to assess the yield, what you are going to get. Suppose if you cultivate a paddy culture, by studying NDVI continuously in every month, you will be able to predict, I am going to get, because my health condition of vegetation is good, I am going to get. You can predict the expected yield, and you can also pasture performance if you want to do with vegetation. That the health is not good, in turn it will reflection will affect in the satellite data. So looking that, you can also go for pasture performance, and rangeland carrying capabilities among others also can be able to study by using this vegetation NDVI data output. It is often directly related to the ground parameters. Yes, it is very important. As I said, it is directly, sometimes indirectly. Many parameters are influencing the greenness of the object. Or NDVI is likely to be studied because of how much area it covers. If it is scatteredly present, no, you will not get amount of reflection more. What is the quantity of vegetation, the area percent in terms of percent? What is photosynthetic activity of the plant? And what is the surface water nearby, or for water facility for the plantation? Or what is the leaf area, LAI, leaf area index? It's the index studied based on the color, based on the health, based on the photosynthesis effect, based on the water, everything. So LAI again helps. That will play a major role for the amount of reflection, and then that will play a major role in the Ndvi calculation, and the amount of biomass present in that area. Generally, you see, you look at the diagram, a healthy vegetation reflectance of near infrared region is more than the red portions. If you apply a formula, of course, it is coming in the next one. If you apply the NDVA is 0.72. You see, healthy vegetation reflect NDVA is near 1. So that is the one. Healthy vegetation absorb most of visible portion and reflect a lot of near infrared portions. So this is near infrared 50% and 8% of red. It again substantiate that healthy vegetation reflects more near infrared. Suppose if the vegetation is under stress because of what scarcity or the health of the vegetation, what will happen? The amount of visible portions will increase, and then the amount of near infrared portions will decrease. You see that your NDVA from 1 it will come down to 0, and then it will go to -1. So that is -1 to 1 is the parameter. If it is slowly coming 0, it means the vegetation is not good. If it is slowly comes to -1, no, that vegetation is almost, you cannot expect that the vegetation will continuously grow. Unhealthy or sparse vegetation reflect more in visible band, less in near infrared band, infrared light. So this is the indication of assessment. And you see, since we know the behavior of plant across the electromagnetic spectrum, we can derive NDVA information by focusing on satellite band that are most sensitive to vegetation information near infrared. So here you can see healthy vegetation which reflects more in near infrared portions, stressed vegetations which reflects very less in shortwave infrared portions, and severely stressed vegetations will be again very low in the far infrared portions. So you see, you look at the reflectance, spectral reflectance curve of its surface features, especially for vegetation. You don't have much reflectance in visible, but you have good amount because of because healthiness second, healthiness third. So this will help for assessing the vegetation. And even bare soil, you see, look at, you have a grass. This is the grass reflectance curve. Red is the grass reflectance curve. And you see a dry grass, if the grass is dry, you see you have higher reflectance, it means percentage it is increased. And the fine snow also, you see, you can correlate even snow and soil at one junction, and then again it is reduced. And black soil, it is the other end. You see, even bare soil on the other hand reflect moderately in both the red and infrared portions of the electromagnetic spectrum. This we will not get confused, but we know the pattern. There are many parameters of interpretation, like you have tone, texture, size, shape, pattern, association. You can take some more parameter, not only depending upon only the what is that, this one formula, and you just look at the shape of the object and you can describe. And this is the formula being used for NDVI, NIR minus red divided by NIR plus red. Near infrared, infrared portion minus visible portion, infrared portion plus visible portion. So you apply, this is the algorithm, NDV algorithm subtracts the red reflectance values from the near infrared and divides the sum of near infrared plus red. And this is the formula being used even for all the assessment of this vegetation. NDVI values are represented as a ratio. That's what I said. The ratio it's from -1, it means it's not healthy. +1, it is healthy. And a value approaching -1 is deep water. It means no vegetation. Value close to 0, minus 0.1 to 0.1 is a barren area of rocks and sand snow. Low positive values approximately 0.2 to 0.4 shrub and grassland. Higher values approximately +1, it indicates the temperature and tropical rainforest. The typical ranges between of about 1 0 minus 0.1 for not a green area. No, you cannot find any greenness. Zero point 0.6 and above for a green area. And this is the formula: greenness minus 1 to 1, and above 1 clouds. What is what is it, the reference which we have taken from the book? Near 0 is rock and bare. Zero point 0.1 to minus 0.2. So this is what I said. Moderate values 0.2 to 0.3 is shrub grass. High value is temperature and tropical rainforest. So close to 0, no greenness. Close to plus 1, highest possible density of green leaves. This is very important. You see 0.8, 0.9, it means it is healthy area of vegetation. 0.2 to 0.4, it is a temperature and tropical rainforest. Minus 0.1, minus 0.1 to 0.6 for a green area. 0.7 to 0.8 is a very bright green area. So application: by using NDVI, you can monitor the drought area, monitor and predict the agriculture production. You can also predict hazardous fire zones. You can also study vegetation monitoring from year to year. You can continuously monitor your land use changes also in the particular area. What is the band used by a different satellite? In Landsat, we take normal near infrared band 4 by band 3 of the red portions. In list 3, 5RS satellites, band 3 is near infrared, band 2 is red. So you have to take 4 plus 3 divided by 4 minus 3, 4 plus 3 plus 2 divided by 3 minus 2. Examples we have done this exercise. This is one. You have your water body. Whatever the value comes, you can describe by studying. That in the last slide. So this is we did for our study area. So what you can look up by using this, will be in position to predict the vegetation characteristics of green object, that is live green object. So this will help for a scientist to work with remote sensing from many angle. You just work and then get it out how this is going to be used for your discipline. So with this discussion of NDV has come to an end. Thank you.